Okay, so for these problems, it says the rate of change of the volume is directly proportional to the square root of volume. Let's break this down for each part. Rate of change of volume, that's dV dt. That means automatically we can cross out A and B. Is equals directly proportional to. Directly proportional means that you have, so the biggest example of it is this. You learned this in Algebra 1, whenever that was, where you take k times some x value, and we say that those are directly proportional to one another. So 1 and 5, and then 2 and 10, and then 3 and 4. And 3 and 15, and you'll notice that each of these is going up by 3, so if I plug in, so k is 5 here, so k is 5, because when I plug in 5 times 1, I get 5, when I plug in 5 times 2, I get 10, and 5 times 3 is 15, and each of these is directly proportional to one another by a factor of 5. In other words, whenever you see directly proportional, put a k in front of it. So this is k times the square root of volume. The square root of volume we said was v. It looks like E has to be our answer. For 14, shown to the right, which of the following differential equations is the slope field given? So the way I solve these problems, I usually look at the signs. So I look at the signs in quadrant 1, x is positive, y is positive, but the slopes are all, they look like these slopes are all positive. In quadrant 4, I'm going counterclockwise. In quadrant 4, it looks like x is positive, y is negative always, like these y values are all negative, but the slope is still positive for some reason. And then when x is in quadrant 3, x is negative and y is negative, but the slopes are negative. And in quadrant 2, x is negative, but y is positive, and the slopes are negative still. So I'm going to look to see, quadrant 1 I never really look at. I'm going to look at quadrants 4, quadrants 3, and quadrants 2 to see what's going on for each one of these differential equations. I'll start with quadrant 4. So I need a positive x and a negative y. By the way, I can cross off b already. The reason I can cross off b is because any number plugged in and squared on the top and bottom is going to yield a positive slope, but I need negative slopes. So because I need negative slopes, I know I can cancel out b, because b only generates positive slopes for me. So let's go to A, and I told you I would test quadrant 4. So if I have a positive slope, a positive x value, and a negative y value, I need a positive slope value, but a positive divided by a negative is negative, and that goes against what quadrant 4 requires with a positive slope. So in other words, A is out. Let's check out C. Again, I have a positive slope, which is cubed, which is a positive number. A negative y value goes in, and I get a negative number out. But I'm supposed to have a positive slope out, so C is out. And this time I'm solving this. I'm looking at the signs of x and y. For D, let's see what happens with D here. For D, I have a positive x value going in, which is a positive number, but a negative y value going out. Well, that gets me a negative slope, but I'm supposed to have a positive. Oh my gosh. And that leaves me with E. And I'll leave it to you to check the rest of these quadrants 3 and 2 if you'd like. For number 42, a puppy weighs 2 pounds at birth. Oh, that's a data point. 2 pounds at birth means that at time 0, I have 2 pounds, which is going to be my weight. And 3.5 pounds 2 months later. Okay, so in 2 months, I have 3.5 pounds. And if the weight of the baby during its first 6 months, that's a long sentence, the weight of the baby during its first 6 months is increasing at a rate proportional to its weight, and how much will the puppy weigh when it's 3 months old? Let's go to that last sentence there. So when the puppy is 3 months old, so when t is 3, what's the weight? So that's what the question is asking. Let's look at that purple sentence. If the weight of the puppy during its first 6 months, okay, is increasing at a rate proportional to its weight. So that's saying that dw dt, the rate proportional to its weight, is now going to be k times w. How did I know that? Well, I knew that because it's telling me, I'm going to get rid of all the colors here. It's telling, I'll put them back in a second. It's telling me that the weight is increasing at a rate proportional to its weight. Proportional to its weight means that you're going to have, did I do proportionality up here? Yes, I did. A rate proportional to its weight means, again, put that k in front, put it in front of the weight. And it's a rate, which means I need dw dt. So that's how I knew that this was the equation. I just want to check something if I did it up here. I did. Okay, so how much will the puppy weigh? Now, when you're given an equation like this, you don't actually have to go back and solve it because, and you may think that you have to go back and solve it because you're only given points on the original function. You don't have to go back and do those 6 steps though, because automatically w of t has to be equal to c e to the kt. Now, why does it have to be true? Well, w prime of t, if we were just take the derivative here, is going to be, and you don't have to do this, I'm just showing you, is going to be the big C there times the derivative of e to the kt is just e to the kt times k. But c e to the kt is w. So this is k times w or w times k, which is exactly what we had before. So in short, you never have to go back through. Whenever you have one of those proportional statements, it's a gift because they're telling you don't have to solve this. W of t is equal to c e to the kt, and now let's start plugging in the points one by one and seeing what we get. So if I plug in 0 for t, I hope you know that you'll have e to the 0. E to the 0 is 1. 2 is on the other side, so you have 2 is equal to c times 1, which means c is equal to 2. So that's first. So now w of t is equal to 2e to the kt. Now let's next plug in our blue point 2, because now I have to solve for k. So now when plugging in 2, I get 2e to the 2k is equal to 3.5. And I can go ahead and solve this here if I want to. 3.5 divided by 2 is 1.75 is equal to e to the 2k. Take the natural log of both sides to solve for k. And if I just divide by a half, I get k. And let's just plug that into a calculator. Let's go and get decimals here. Natural log of 1.75 divided by 2. Natural log of 1.75. Okay, so I get 0.2798. 0.2798. Okay, so that's what my k value is. So now I'm going to plug in 3 into my equation. So now my equation is y is equal to 2e to the 0.2798 t. And now if I plug in 3 into that, and by the way, it shouldn't be y, it should be w of t. Let me just change that. Oh, this looks horrible. Don't tell Ms. Schwartz that my handwriting and my organization is this bad. Okay, so w of 3 is going to be equal to, so let's see here, I'm just going to do some trickery here. A is equal to, we said w of tx is going to be equal to ue to the ax. So w of 3 is going to be equal to 4.63. 4.63, and is that an option? It is. B is my answer. Thanks for watching, guys.